Going to explore a little bit of the AI security privacy guidance from OWASP and how to practically integrate that. Really appreciate you all joining us for the webinar. Just logistically, so everyone knows as we're jumping in here, we will be monitoring both the chat and the Q&A panel within Zoom. So please add your questions throughout the webinar to either of those places, chat or Q&A, and we will be sure to answer those questions at the end of the webinar. And Sharon, who's helping me run the webinar, he'll feed those through so that we can get those answered at the end. So make sure and add your questions throughout the webinar. This will also be recorded and posted on YouTube after the webinar. And we'll share the slides link for you all. So if you don't want to, grab a quick screenshot or something like that, certainly you're welcome to. But we will share those slides towards the end of the webinar and post the webinar on YouTube for the recording. Okay, let's not waste any more time and jump right into the content. Share my screen. Okay, there we go. Okay, so yeah, today we're going to be talking a little bit through the OWASP guidance for AI security. There is a lot of this, of course, that has come out, and we're going to try to distill down some of the main practical guidance for you as you're trying to make your AI applications more secure. I'm Daniel Whitenack. I'm CEO of Prediction Guard. Prediction Guard is a company that is providing secure private AI systems for companies in regulated industries or with security or privacy sensitive use cases, like the one that's shown in the image there of a kind of medic co-pilot system being developed within a military context. If you're interested more in that customer story, you can visit that video link. But we also are actively participating as a company and as individuals in terms of education and leadership around AI security and privacy best practices, being involved in committees and working groups through things like ML Commons and OWASP, but also through educational outlets like the Practical AI podcast, which I co-host with Chris Benson from Lockheed Martin, and also teaching occasionally and collaborating with Purdue University. Just to let you know before I forget, we do have a couple other upcoming webinars. You can go to Luma at Prediction Guard and/or practicalai.fm/webinars to find the links to these. Would really love to see you at these upcoming webinars where we'll be talking about some other things like integrations of AI into existing software and kind of harmonizing AI tools in a very fragmented ecosystem. So make sure and go register for those webinars as well to get the updates. But let's go ahead and jump into the topic of today, which is really kind of moving from what looks to be kind of very useful but potentially overwhelming guidance around AI security and privacy from OWASP to actual principles that you can apply in your own development work. So what I'd like to do is just describe a little bit of OWASP specifically. So OWASP is this organization that has, even before generative AI, certainly provided kind of security, privacy, best practices, standards, frameworks that are generally accepted as best practices across software development and technology. OWASP has started this Gen AI security project, and this actually includes a lot of different resources. And actually, if you scroll down, you'll be able to see kind of the affiliated organizations here, which include, names that you will recognize, like NIST and others. And they have various initiatives. So they have kind of a top 10 list of the kind of top security privacy risks related to LLM-based applications or Gen AI applications, but they also have a lot of other efforts like checklists that are helpful in terms of securing your applications. They have a whole study related to the emerging threats related to agentic workflows. And so there's certainly no shortage of things to explore here. I definitely recommend you kind of explore, go to genai.owasp.org, and you can look at all the white papers and guidance and checklists and that sort of thing. But there is a lot here. If you're like me, sometimes this can be a little bit overwhelming. Sort of, where do I start? What are the top most interesting and useful things that I can do to get the kind of best bang for my buck? How do I make most progress in the quickest way in terms of making my AI applications more secure and more privacy conserving? So that's what we're going to explore in this webinar. And if you're also interested in kind of a little bit more context around this, there is a Practical AI podcast episode where we talk to a representative that was in the kind of main effort around the OWASP's top 10 around LLMs. So would definitely recommend also kind of follow up with that episode 286 of Practical AI. But in order to talk about the security, privacy, threat concerns related to AI applications, first we need to maybe have a reference architecture in our mind for how many AI applications are actually operating, because a lot of what we'll talk about related to the OWASP guidance really doesn't make any sense if we don't have that reference architecture in mind. So that's what I'd like to present. And this is really kind of, it's a simplified form of the kind of archetypal use cases that we see being applied across a variety of industries, from manufacturing to healthcare to defense to finance. Really, there is a kind of core set of things that it seems like almost everyone that's implementing AI things, they're implementing something like this reference architecture. So let me kind of talk through that. So let's assume that we have an AI application of some type. That could be a chat bot, it could be an AI automation, it could be a kind of widget in some kind of existing software. But there's an AI application layer. So this is code that is either a web application or an API or some long-running service, but this is code that's running at the application layer. And that application layer is building the kind of business logic of our AI application. Again, whether that be a chat bot or an automation or anything in that vein. Now, this AI application will need to make calls into an AI model. And specifically, and most often, that will include kind of prompt inputs and completion outputs if we're talking about LLMs. So in a chat application, sending a message thread and getting an assistant message back, or in a text to SQL application, sending in a prompt and getting the SQL completion back. There's a variety of ways this could work, but that AI application will necessarily need to make calls into a model that is running somewhere. Now, in certain cases, you may be just connecting over an API to a model product, like a closed model provider like OpenAI or Anthropic. In other cases, you will be connecting to maybe a model that you are hosting, either with an open source tool like a VLLM or through kind of a platform like Prediction Guard. But whether it's, Prediction Guard or an open source hosting or OpenAI hosting a model, somewhere there's a model running on a server. And on that server, it has loaded, that inference framework has loaded model parameters into a model architecture that's implemented in code. And so that model really has two components. It has the model parameters, like sometimes you've heard maybe of this model having 600 billion parameters or something. Those model parameters are loaded into that inference server into memory, and they parameterize a kind of model architecture, like a transformer-based LLM architecture. And that's what the model inference server uses to translate your prompt into a completion. So somewhere this is happening, again, whether that's in your infrastructure or not. And often it's not just one model that we're using, but we're using multiple models. So in pretty much every AI application that we see being developed, it's almost never a kind of one model show. You don't just have a single model that is completing everything that you need in your application. Often you need a language model, you need a vision model, you need embeddings, you need re-rank, you need safeguard models, transcription, document extraction models. So many times, let's assume for the case of this reference architecture, we're running multiple models. Now, along with that AI application, often that AI application will also be connected to a vector database, which includes kind of this curated unstructured data that might be referenced in an AI application. So in a chatbot application that helps HR, maybe that's onboarding materials or policies or that sort of thing. In a manufacturing scenario, maybe it's SOPs or equipment manuals or these sorts of things. It's the unstructured data that can be referenced by that AI application via retrieving that data semantically and getting kind of documents and metadata in return that's kind of integrated into the application on the fly as users make their interactions with the application. And then finally, we have maybe a set of connected tools. This differs from the vector database, where in the vector database case, we're kind of loading a set of static information, static data, static documents into the vector database and getting those, via retrieval. Whereas tools are kind of these live systems that the AI application can connect to. So for example, if I want my AI application to book a car for me on kayak.com, that might need a connection to the kayak.com API, where the AI application generates the API calls to kayak.com, and those are sent to the kayak.com API. Or maybe in a analytics case, I have a connected manufacturing database, and I want to know how many of this widget was made at this facility last month. I can generate the SQL query and then interact with that external tool. So these are kind of live systems that we're connecting to over some structured calls like REST API calls or SQL calls, etc. So again, think about this reference architecture. We have some main components here: the AI application, tools, vector database, and model inference servers. Okay, so now that we have that, let's kind of distill down, what is a very kind of large amount of guidance from OWASP, which I, again, would recommend that you look at in a bunch of detail and analyze after this. But if we take a look at all of that guidance from the OWASP top 10 for Gen AI, the agentic threats and mitigations, the checklist information from OWASP, what I've done here is I've distilled down kind of 4 key principles that we're going to go through. And we're going to modify this reference architecture to implement those 4 key principles, such that you could maybe take this reference architecture and then map that back to where you need to make changes in your own AI applications in order to fit these kind of security privacy best practices. So principle number 1 here is that we want to contain model and agent capabilities. So contain model agent capabilities. This is principle number 1. And I'm going to go through kind of explaining what that means in a few bullets for each of these principles. So the first thing that this means to contain model and agent capabilities is that actually you want to minimize the amount of tools that you have integrated, and kind of avoid open-ended ones like instead of accessing the full kayak.com API, maybe you just need access to one particular endpoint. You can thus restrict each tool's functionality and the permissions associated with those tools, where basically you're giving kind of the least amount of tool access, tool functionality, and authentication to each of these tools to restrict that blast radius. So in terms of our reference architecture, this would really come in kind of this bottom left-hand side of the reference architecture, where instead of just saying, okay, I'm going to integrate all the tools that my AI application might ever need. I'm going to integrate these APIs and those APIs and these databases and those databases. You should really do this in kind of a more curated way and only add the tools that you need to add. So maybe I only need access to this one endpoint in this API and this database, maybe even just with these tables in this database. And so you want to restrict the scope of the total tools that are available to your application. And you want to make sure that the tool calls that are accessing those tools have appropriate kind of least privilege access and authentication, and rate limiting, right? So your AI application can't just overload the APIs or the databases that it's connecting to, and it only has kind of least privilege access. So in the text to SQL case, for example, if I'm querying that manufacturing database, maybe I want, for instance, those calls to be made with a role on the database that's read only, right? And maybe only accessing certain tables of that database, or maybe accessing even just a clone of that database that's not the live database, but a kind of analytics clone. And certainly with the appropriate authentication for things like API calls. So that's kind of the first thing that this principle number one means. Let me see here. Okay. The second thing here, sorry about that. I don't know why my slides weren't advancing. The second thing that this means is really to apply user context and least privilege. So what should happen is that you're executing actions in a user's context, and that affects the downstream things. So for example, if your AI application has access to a live database or an API that's maybe running as a microservice in your infrastructure or supporting maybe your other applications, your AI application should also authenticate that user and use that user's role or security profile or access to affect how you access the downstream systems. And so this is now not just any end users logging into my AI application, but this is authenticated users logging into my end user application, right? And I can use that authentication then and connect it with the previous point, which is how I access these downstream tools. If a certain user, for example, has only access to certain data in the database, I can use their authenticated login to make sure that I'm not letting the AI application access data for that user that they shouldn't have access to. Okay. The third piece of this kind of containing of model agent capabilities is to avoid open-ended automation. And this really gets down to requiring human approvals for high impact steps that are triggered by the AI application. If you remember, Anthropic had this kind of very hyped study recently that where they proved that an AI agent could blackmail users and maybe shut down certain systems if it deemed that consistent with the goals of the AI agent. Well, that will never happen, right? If certain types of automations and certain kind of high impact steps are not allowed for the AI agent or the AI application without a human kind of approval. So they might be generated as kind of a dry run type of scenario, which is approved by a human agent. And so here, let's say, take another example outside of the Anthropic case. Again, if we have any kind of system that's connected to a live database, and maybe any action that would modify that database. So add data to it or modify the schema or drop or delete information that would actually be generated into a moderation system that would be reviewed by actual human moderators or admins to make sure that that's a change that needs to be made. People are using a lot of code development tools now, and a good example of this also is kind of AI generated pull requests, right? If you have a code base and you have an AI agent that's looking at that code base, and you maybe give it a feature request and have the AI agent make a pull request, maybe you require that there's human review of that pull request rather than just automatically merging that pull request in, right, without any kind of human review. Okay, moving on. Let's go to principle number 2, and principle number 2 is to treat all inputs and outputs as untrusted. And these are mainly thinking about inputs and outputs to the models here. So you could think about this as applying a kind of zero trust policy to all inputs and outputs to models, including kind of filtering and validating model inputs and outputs. And regardless of kind of how you've tested the model or system, you should always think about those model outputs, especially as potentially harmful in the context that you're operating in. And so you really want to validate and prove to yourself, whether that's automated or not, that you can treat these model outputs and actually supply them to, for example, run code or access databases or access tools. So the way that this might work in kind of our reference architecture here is adding a kind of model firewall system into either the layer between the AI application and the model inference servers, or actually providing input and output validation in the actual AI application layer. Both of these are possible. It just kind of matters maybe how you want to do that integration. There's various guardrailing systems, firewall type systems out there that will allow you to, from both an open source perspective and a closed perspective, integrate this kind of firewall system or input output validations. Just by way of example here, in our API, we have a number of these safeguards available, like factual consistency checking, blocking prompt injections, filtering, masking, removing PII, filtering toxicity out of the model. And so if you want to think of these are available as kind of that other system that's running the kind of firewalling tools, or you can integrate that directly kind of via an SDK. And so this is just by way of example, a way that you can kind of integrate those things into your system. All right. Let me share my screen here again. So the other thing in terms of treating inputs and outputs as untrusted is really making sure that you follow maybe some suggested and recommended kind of best practice around application development. So I see this a lot in terms of the customers that we interact with, or even people that I hear about developing AI things. For some reason, it seems like when people develop AI applications, they almost throw out all kind of industry known best practices around application development in general, like using authentication and using encryption and all of these sorts of things. And so the other kind of key piece here is that you want to treat your application as having threat vectors and secure that application according to best practices, because especially if you expose that application publicly, anyone could access that application and try to do all sorts of various things, whether those are AI related risks or just normal related risks. And so following something like the OWASP ASVS guidance, which I've linked here, you can look at in the slides to make sure that you're sanitizing application inputs, outputs, and you're following kind of the best practices at the application level. And so you want to think not just that you're developing cool AI functionality, but this is an actual software application. It's either an API, it's a web app, it's whatever it is, and you want that AI application to be securely designed. And thankfully, there's a lot of guidance out there from OWASP and others of how to do that. And so it's not just about these kind of net new AI, security concerns, but also about kind of application development from that perspective. The other thing that I'll mention here in terms of inputs and outputs is that most of these AI systems, as I mentioned, rely on external tools and systems and external sources of data for augmentation, right? Like in a RAG system, you rely on external vector database. And so having policies for content security basically means that you're limiting what could be loaded into the application to kind of known data sources or formats or types of content. So what you want to be thinking about here is I don't want to just load everything that I possibly have access into my company into my vector database because who knows what's in there. I want to create a curated versioned vector database that includes high quality data because that'll make my AI application better, but also includes only data that I explicitly expect my AI application to be able to handle and process. And in this way, you kind of run into potential problematic scenarios where you start having maybe end users or other people be able to add in their own data to the vector database, which could kind of poison the vector database in that sense. You also want to, again, curate those tools to not just any tool that you have access to, but a curated set of tools which provide only expected responses and data. So, maybe an API call returns a JSON body, but you really only need to process this field from the JSON body. You should really not have your application even parse or use any of the other fields because you really only want access to that one. And so you only provide access to that one field to the AI application. But this all is kind of related to this idea of content security. Okay, so then principle 3, we're going to think about securing the AI supply chain. In traditional kind of security practice, there is this kind of thought about supply chain vulnerabilities, not related to AI models, but related to things maybe like open source code, right? So when you are deploying an application in a secure environment, for instance, or providing software to regulated industries, often you'll have to scan that software to develop what's called a SBOM, which essentially is a bill of materials for all of the dependencies of that software, so that you know exactly what dependencies from a software perspective are kind of included when you ship code into an environment. So now we're in an AI perspective or an AI environment, and we want to know exactly what are all the kind of AI assets, code, data, and otherwise that are being shipped into the environment where I'm running my AI application. So the idea here is that you want to maintain an SBOM, not just for code, because there is code involved, but also for things like models and data sets that you're integrating. So what is the actual dependencies that are included in terms of those models and data sets? And to that end, you don't just want any kind of it's not enough to just say sort of GPT-5, right? Because in these types of scenarios, that's a productized model, right? Which is changing under the hood, and that alias of that model could mean a lot of things, which is also why often in research papers it's hard to reference closed models because they constantly change if you can't pin a version. And so that's why in a lot of scenarios that we see, especially if people are concerned with security and privacy, part of that story is really using open models that you can actually download verify the provenance of that model, store it in your own infrastructure, in your own model vault, know exactly what model version you're using, know exactly what files are being loaded into, that model inference server, so that you can actually maintain, a signature and hashes for that model and make sure that you're not always pulling from external third-party sources. You know exactly what model you're using, where it's coming from, the provenance of that, the version of that, to really kind of understand the scope of your AI supply chain. And as you do that, right, that's necessarily going to change over time. You will likely update your models. You will update your dependencies. Maybe you're using LangChain as something to kind of build part of your application to run your RAG pipeline or whatever it is. Well, that framework is going to update over time, right? And so you will want to necessarily update those dependencies because there will be security patches and fixes to those. And so this isn't something that's static. You want to update those dependencies over time. You also need to sort of audit those dependencies to make sure you understand the model and framework licenses and terms. So just to give an example, like a llama-based model has use restrictions around industrial usage or military usage, right? So if you're working in that context, you can't be using that model. Closed model providers, even if they're not training on your data, you're still subject to their terms and service, which, for example, means that the outputs of the models, let's say you use an OpenAI or something like that, you don't have full rights to do anything with that output, like train your own model, right? And so you need to kind of audit and understand the model and framework licenses and dependencies there. So in this picture, if we look kind of at that bottom right-hand side, we're moving from just any model parameters and architecture that are loaded into a model server or even a closed system that you don't have access to a very transparent model inference server where you've validated the model parameters. You know the exact version of those, you've audited the licenses, and you have a fully patched kind of both in from the AI application side and from the model inference server side, fully patched dependencies from frameworks like LangChain and that sort of thing to inference frameworks like a VLLM or TEI or whatever you're using. Okay. And then here in this last piece, we want to make sure on this kind of securing the AI supply chain front that we scan our AI assets. So in addition to kind of validating and verifying the model versions and kind of the provenance of those, the license of those, we do actually want to understand from a, testing and evaluation perspective if these models have kind of issues related to bias or certain sensitivities to things like prompt injection, uh, sensitive data disclosure, toxicity coming out of the models, et cetera. Because one thing that's true is no model is fully aligned, right? And so there will always be a bias of a model. There'll always be a tendency of a model to misbehave in certain ways. And so there's various ways to scan these AI assets. Everything from in Hugging Face, they have built-in scanning of model files from like Scan AI, for example, that will provide you with little icons in Hugging Face to ensure that files are of the right format and there doesn't seem to be any suspicious things in the binary files, for example. So those are static checks. But there's also kind of automated red teaming that you can do. In the Prediction Guard platform, we have a model scanning functionality that will look for vulnerabilities, kind of the level of vulnerabilities to things like prompt injection or sensitive data disclosure, etc. So these are things that you can run as you bring the AI assets into your environment. So now we're going not just from validated models and parameters and patched model architectures implemented in code to both scanned code and scanned model assets, which the translation of this from the traditional AI or the traditional security context is we've been scanning code for a long time. Now we need to move into this phase of scanning models for potential vulnerabilities and problematic behavior. Okay. The last principle that I want to highlight here before kicking it over to questions is that we need to make security checks continuous. And what I mean by this is not just treating kind of each input as something that you need to moderate or output that you need to validate, which should maybe be part of your AI application, but you actually want to be treating these sorts of events as kind of net new SIEM or security events that go to kind of centralized monitoring and alerting systems. Because if you think about something like a prompt injection, it's unlikely that someone's going to be able to prompt inject your AI application in one attempt. They're going to do it kind of like a password hacking thing where they try hundreds or thousands of things. And so, actually, tracking the behavior of suspicious patterns over time is very important. And you don't want this to be something segmented just to the AI application layer, but you want this to be integrated into your centralized logging and alerting if that's something that you have in place, which if you're in a regulated industry like healthcare, you certainly already have that in place because hopefully you're HIPAA compliant and that's a requirement for HIPAA. In other cases, it's very typical to have that as well. So here you want this kind of centralized monitoring and alerting system that is plugged into your application layer and is actually alerting back to your security team. Just by way of example here, if we go to, I'll just pull up our admin panel here. If you look at this sort of, we have this security alerts pane, which actually shows kind of per time these kind of PII that's being requested out of the systems, prompt injections that are being attempted, toxicity into or out of the model. We log these as kind of live events that are output of the system as open telemetry data. So this can go back to your centralized logging and alerting systems. Okay. And the last thing here that I'll mention on kind of principle four and making AI security checks continuous is that you really need to not think about the threat modeling that you do for your AI application as a one-time event. Like, hey, let's evaluate all of the security risks of our AI application. Okay, good. We've evaluated all of them. Now we push it into production and we never think about that again. Obviously, I'm being a bit hyperbolic here, but the thing that you want to think about is keeping that threat modeling up to date. So various things are going to change. You're going to change the model you're using. You're going to update your vector database. You're going to add a tool to the set of tools that's available to your AI application. You're going to modify the business logic of that AI application. And so you need to think kind of at every release of your AI application, hey, what changed that should trigger us to rethink about, evaluation, changing our security setup, the things that we're monitoring, all of those sorts of things. And there are various kind of checklists and frameworks that are available to kind of help you along the way, so you don't always have to like come up with this from scratch on every release. You can use frameworks like Maestro, which is referenced in the OWASP guidance, or various checklists to do this. I've linked here in a second. I'll conclude and give some resources, but I've included a link to the kind of Maestro framework if you're curious to look at that. That's kind of a extension of traditional software engineering, threat modeling frameworks to the AI space. And that's a framework you could use as you're kind of continuously updating these threat models or creating checklists. You also need to think about updating your, red teaming processes as you release things. So, very typical scenario that I see is you do a lot of red teaming on, let's say, a RAG application when you first release that into production. And then you continuously make updates to the vector database, not realizing that that vector database and those changes to the vector database are really changing how your AI application behaves. And so you kind of need to update that red teaming also as you update versions of your database, et cetera. Okay. So I'm going to go ahead and conclude, provide a few resources, and then hopefully there'll be a good set of questions that we can discuss as we go along. So just in conclusion, I would very much recommend that you look at the kind of general link here to the OWASP Gen AI Security project. There's way more rich information that there's no way I could cover that in 45 minutes or even a week of webinars. And so you really should explore that and explore the resources there. As I mentioned, we have upcoming webinars, but also I've linked this AI threat modeling framework called Maestro here, which you might want to take a look at as you're going through. Also, there's a couple of relevant practical AI podcast episodes that if you haven't listened to, one from the representative from OWASP, that's 286, and also one from Donato at With Secure, which is a great discussion of AI security, episode 320. And so, yeah, please reach out. Make sure that you join, our Discord or reach out via email if you have any questions. We would love to be helpful to you. Please let us know if you want to kind of demo of the AI system that I showed here. And looking forward to the questions. I'll go ahead and pause and open it up. Awesome. Let's see, questions that have come in. We built an internal AI application. It's been working great. So it'd be good to know how frequent to have these checks done after deployment. So let's say that you have this internal AI application. Great question. It's been working great. And the temptation, I think, in that case is to kind of from an anecdotal standpoint, understand that the application is working great, but maybe not from a quantitative perspective, have a way to know maybe if the AI application is going off the rails a little bit in certain respects or having certain problematic behavior. And so what I would recommend is actually creating a kind of test suite for your internal application that you can rerun automatically as you make changes to your internal app. So part of that test suite should include kind of performance related things like, hey, are we answering these types of questions correctly, right? Those are things that are kind of minimum functionality. But it should also include these kind of security related things. So what if someone asks this type of question and tries to prompt inject our system to get access to admin information or our system prompt? What happens does our system give a refusal? Or what happens if the user tries to output toxicity from the system? And so you can integrate those things into your kind of test suite. And as you're making changes to your application, you could run that as part of your CI/CD pipeline. So in that sense, every time your application is updated, you could, in the build process, run that test suite as kind of a minimum set of functionality testing that you need to evaluate. Then I think there's things that trigger maybe a wider set of evaluation, testing, and validation. Maybe those are things like model changes or significant changes to your vector database or your set of tools that might trigger kind of a more formal red teaming exercise with your team on that application. Okay, so yeah, and then there was a question, what is your take on the recent Replit incident where during vibe coding an AI agent dropped a production database? So this is a great example of, I think, where reducing the blast radius, as I mentioned in one of the principles, that really is a key thing to make sure these sorts of things don't happen. Now, I know there's been a lot of apologies from Replit, and I think that they've dealt with those types of issues, hopefully. But think about in any case where an AI agent has access to a database, really, I think you could kind of do two things to make this scenario much less likely or maybe impossible. One of those is you could make it to where the credentials that the AI application has to the database are read only. And if the AI, so then that creates a scenario where you're not deleting, dropping the database, et cetera. Secondly, you may need to or want to, in the development case, actually make changes to the database schema or other things. And those could trigger that sort of moderation that I talked with before. So you could just have the AI agent make a kind of dry run of the changes and present those to a user for approval. So I think that's yeah, it's definitely an interesting and very good example of maybe putting some of these the need for putting some of these practices in place. Other question is using the new OpenAI open source model safe. So if you haven't heard, OpenAI is open again, apparently. They recently released some open source models, and these seem to behave quite well. Maybe I'll say a few things about these new OpenAI open source models. Number one, each model that is released has its own sort of biases and personality, if you want to think about it like that. So if you're thinking about integrating these models into your own applications, really you want to be thinking about that as quantitatively as you can in terms of this testing. So as I mentioned in relation to the previous question, if you have a test suite of questions and potentially problematic scenarios that are specific to your use case, then you can test that new model against those things that are relevant to your context. Because what happens is there are publicly released safety data sets, and these data sets are often used for like safety benchmarks, quote unquote. But if I'm a model builder, I have access to that data when I'm training my model, right? And so if you run OpenAI, the model across some of these public safety benchmarks, it will do amazingly well. Now, I'm not saying that they did train on that data. They might have, I don't know. But regardless, it was publicly available when they trained the model, right? So you can't just say, oh, it does well on this public safety benchmark, and so it's safe for use in my environment. You want to run your own tests and convince yourself of things that the model has necessarily not seen in the public. So I think that's true of any model, whether it's the open AI, open source models, or others. Now, we are working on some model scanning of the OpenAI open source models and have already done a little bit of that. I'm not quite ready to release our study there, and hopefully we'll write a blog post or even have a webinar about that specifically. But yeah, I think there's also no rush to update to any models as they come out. There's always this phase where a new model comes out, people are unsure. People will do testing of that model and validate kind of in the wild how it behaves versus kind of the benchmarks that might have been gamed or at least are unrepresentative of the real scenario. Okay. Let's see. Those look like the questions that have come up. I see that Sharon shared some of the links there. I want to thank you all again for joining today, spending time with us talking about AI security, privacy best practices, and the OWASP guidance. Please again reach out, sign up for the upcoming webinars, and check out the slides and the links in the slides. Really appreciate you all, and thanks for joining.